Hey everyone, Dr. Keith again. So let's keep going in databases. This is the last thing we're going to learn in this module. You've gone through ERDs, you've diagrammed out database relationships, you've created tables and relationships in Access, you've created queries in Access. Now that you get the basic idea of queries, let's learn the underlying structured query language that's used to do everything we basically do in databases. So SQL can be used to update, edit, delete, add records, all these things, but the most likely purpose you'll be using SQL for is to do what's called select, or read or get or query data to use in your analyses, solving business problems, stuff like that. So let's go ahead and scroll down here. We're going to download this SQL database. This is just the same Gold Star database we've been working with some minor edits to it. So go ahead and get a new copy instead of using the one from the previous chapter. Once that opens up, we're going to do the exact same thing we did before, enable content. We're going to create queries, but instead of being in design view, we're going to go to the SQL view and do all of these same things that we did before with some minor differences. So let's start with this one. Write a SQL statement that will find all employees who have an average performance rating. We're going to skip some of the easier ones and focus just on a few. So come here to create. You can click query design again, but the difference is now I want you to close out this show table and go straight to SQL view. So if you don't see SQL right there, click the down arrow and go to SQL view. So there are keywords in the SQL query language, or that's redundant, in SQL. Select is one of them. We often like to write our keywords that are understood by the query by the SQL engine. We like to write them in uppercase just to simply separate them. It's for readability. They don't have to be in uppercase. Semicolons end SQL statements. I'm actually going to move this down here. So the first word we have is our select, and you might have remembered from the last video, if you looked under the hood at all, how this works. But we use select to list the fields that we want to display. Now here it says find all employees who have an average performance rating. It doesn't say which fields to show. So do you remember what we used last time to select all fields? That's right, it's the star. So there are multiple ways to do any one thing in SQL, and this is true in IS in general. There's often many ways to do the same thing, and I'll teach you a couple of those differences. For now, use that select star, and there's two other keywords I want you to get used to knowing and using. Select from and where. Select always refers to the field names. So select all field names. From always refers to the database table. So we need to type this name in exactly. This is going to be from the employee table. Now you might notice sometimes, especially when we did the last query design view, it used the star kind of like this, employee.star. So this will work, but the reason why we don't need the employee, it's usually we refer to fields as table name dot field name, but the reason why we don't have to use that is because we're only selecting fields from the employee table and no other tables. So it'll know by default that we're selecting everything from the employee table, so there's no need to use the employee dot, although that notation is commonly used. So where, this is our criteria, just as before when we had that little criteria row in SQL Design View. Now we're going to spell things out a bit more explicitly using this where clause. So where, we use field names and values. So in this case we want employees who have an average performance rating. So let's check and see what that field's called. It's called performance, so it's important that we spell it just right. So we're going to say where performance equals, I've got the worst memory, average. There we go. Average. Remember, double quotes are needed for text. Before, we didn't have to use this equal sign when we use the query design view, but we need it here. We're saying where the field called performance equals average. Now, if we were selecting from more than one table, and the same field name called performance was listed exactly the same in multiple tables, then we would have to say explicitly employee.performance. We have to refer to the table that we're pulling performance from. Similarly up here, if we're pulling from more than one table and we only wanted all the fields from one table, we'd have to say table name.star to get just the fields from that table. So this is standard notation. This will work perfectly fine. If I go to datasheet view, here we go. It's given me everybody who has an average performance rating and all of their fields. But I could just, and here's what it looks like in the query design view. Here's that employee dot star criteria. Put an average right here. Back to SQL. But it would work just as well if I take this out and I take this out, because we're only using one table and there's only one field called performance. So once again, run, same thing, there it is, and that's it. So a couple other things to know about SQL. First of all, white space for the most part is ignored, meaning I can put all of this on the same line and it's going to work just as well. So why do we break it down into multiple lines? Simply to make it readable and easier to follow along with. That's all. So white space does matter in the sense that we need one space between each keyword, between equal signs, stuff like that. But white space down the page doesn't matter. Or if I did this, added a bunch of spaces in right here for whatever weird reason, it would still work just fine. Alright, so let's save this, query 1, and close it. Yep, save, query 1. And let's make the next one. Query design, close this out, go to SQL view. So during this tutorial, and when you're practicing SQL, very important, don't go and be tempted to use design view. I know you're more familiar with that because you practiced it in the last class, but you're going to be much faster in the workplace if you can write SQL directly. Sometimes the design view, you just can't get it to do what you want it to do, and it's a lot easier and quicker if you write it yourself. Also, check with your instructor. You may have an exam that forces you to be able to have to read SQL. For example, with my students, I have a multiple choice exam where I'll say, here's the database, here's the ERD, which of the following SQL statements will return X, Y, and Z. And then they'll have A, B, C, and D, and there'll be different SQL code, and they'll have to identify the right one. So check with your instructor to be sure. All right, let's do the next one. Write an SQL statement that will show all employees that make $75,000 or more. Display last name, first name, hire date, salary, order by salary descending. Not a problem. All right, select. Let's see what these are named. So it's last name with no spaces, first name with no spaces. All right, that's good to know. Whoops. Yep, save. So select last name, first name. Does it matter if we follow capitalization with the field names? No, it doesn't. But I do it because I'm obsessive compulsive or something like that. Hire date, salary, order by salary descending. Okay, before we get to order by, we need to say what table we're pulling it from and what the criteria is. So from the table is called employee where salary greater than 75,000. No commas, no dollar signs, nothing like that. Let's make sure we got that right. So, 75 or more. So it's actually greater than or equal to, which we specify like that. There are no spaces in between those. It's just greater than, equal to sign. So let's view it. That looks right. They all make more than 75,000. All we have to do now is order it by salary in descending order. So let's put in salary. So order by always comes after the where clause at the very end. Order by salary. And if I leave it like that, the default is it's going to order it ascending. So from smallest to highest, or from A to Z. If I want it to be descending, then I need to come in here and say order by salary. DEST is the keyword. ASC is ascending, but there's no point since that's the default. So I just, if it's descending, add that in, run, there we go, highest to lowest. Okay, not so bad, right? I mean, really this language is pretty semantic or self-explanatory. Select which fields, from, what table, where, your criteria, how do you want to order it. So, if you've been able to make this work, you're well on your way to becoming a SQL master. Only a few more little things to cover. Alright, save this. Query 2, let's do the next one. Alright, write a SQL statement that will show all employees hired after this date, order by hire date ascending, display last name and hire date. Alright, cool. This one should be pretty easy. Close, SQL view. Alright, select last name, hire date. That's it. From employee, where hire date, it was after that date, right? Don't forget, we need the hashtags for dates, only for dates, 12, I forgot what it was, 31.95. Okay, anything else? Order by hire date in ascending order, not a problem. Order by hire date. So don't forget, it's not wrong if I go ahead and put ascending in there. It's just redundant. Okay, let's run that. There we go. Everyone is hired after that date, and it's in ascending order. Perfect. Save it, close it, move on. All right. Write a SQL statement that will show all employees who work in Georgia. Show last name, first name, and location city fields. Okay, here's where it gets interesting. So far, what we've done has been pretty easy. But now it's time to join tables. Now, when we did this in Design View, it was really simple because we had created those relationships using that database tool, relationships. And that meant that it wrote the joins for us. Now we're going to have to write the joins ourselves. This is what's going to take the majority of the learning for SQL. There are lots of different types of joins, and we don't have time to teach all of them in this class. There's inner joins, outer joins, left joins, right joins. We're going to do one type, an inner join, and there's multiple ways to do it, and we're going to learn just one way. It's not the way that Access likes to do it, but it works exactly the same. The reason why that's important is this means that you can't, when you get stuck, switch over to Design View, make your join there, and then go back to SQL View, because it's going to be different, and we're going to teach you a different way to do it. I think the way that I'm going to teach you how to do it is it's a bit more logical. It makes more sense to people, and it's easier to learn. So that's why I'm going to teach you this way. So we need which tables to get this data from. We need location, city, and employee. All right, create, query design, SQL. All right, let's see what our field names are again. Last name, first name, location, city. Let's see if that's how it's listed in the location table. Yep, location, city. And then we want everybody who's in Georgia. And there's only one city in Georgia, but that's okay. We'll use state there as our criteria field. First name, last name, location, city. From. Now here's the key. This comes from one table, and this comes from another table. We need two tables, from employee, comma, location. That's the name of these two tables. Okay, here's where the criteria gets a bit trickier. So the type of join I'm going to teach you is a join that we specify right here in the where clause. Okay, and again, this is only one type, but this one will handle the majority of the situations you run into. So we need to tell it how employee and location are related. If we look at database tools, relationships, the way that these are related is on the location ID to ID and location field. So in the location table, here it's named ID, and it's related to what's called location ID and employee. So what we need to do is tell the SQL that these two fields match up. And here's how we do that. Close this out. We're going to say where employee dot, in that table it's called location ID, equals location dot, and in that table it's called ID with a lowercase d. Again, I don't think capitalization actually matters. That's just my obsessive compulsiveness or whatever you want to call it coming out. Okay, so this right here is what says where these records match up. Also, there's another criteria. The other criteria is employees who work in Georgia. Okay, so I'm going to come down here, space it, and say and. I could say location dot state equals GA, However, there is no field called state in the employee table. So I don't really need to tell it that it's in the location table. I could just write state just like that. Alright, so it seems like this is multiple criteria, but really the first one right here is just joining the tables together. And then this is really our only one true criteria. Give me everybody who works in Georgia. Is that it? Yep. Everybody that works in Georgia, show last name, first name, location, city. I think that's it. Also, right here, notice I spaced and in. It's because I like these things to line up in my where clause. I think it's a bit easier to read. It would have been just fine to put it right back here. No difference at all. Okay, let's run that. Cool. Location, city, all Atlanta. Looks good. Let's close it out. Save. Query 4. All right, moving right along. Write a SQL statement that will show all the employees that have a last name that starts with A or M. Display last name, first name, and performance, order by last name. Any join needed? Doesn't look like it. Okay, let's do that one. Query design, SQL. Okay, select last name, first name, and performance. Last name, first name, performance from employee where. Okay, this is just back to our wildcard characters again. Looks like we've also got an order by in there. Let's do that one. That's easy. Last name. Order by last name. Yep. Okay. So I have a last name that starts with A or M. You should probably be able to do this one on your own. Take a second and see if you can remember and make it work. Okay. Here's our criteria. Our last name. We don't use an equal sign because remember, whenever we use a wildcard character, we use instead the keyword like. So our last name like, I'm going to put A and then star after A. That means it has to start with the letter A, and it doesn't matter what's after it, and it doesn't matter how many characters are after it. That's how you make sure you get the last name that starts with A. And then or last name like, was it M? I think it was. Yep. A or M. Order by last name. Run that one. Last name, here we go, Adams, Adamson, and all the M's. So let me go back to the SQL. Something else you can do if you prefer this on a where clause, kind of like with the and, you might also have that or in like that so you can sort of see all the criteria lined up together. Again, totally personal preference. I think we'll stick with this. Well, depending on your instructor, I like to stick with this on my multiple choice exams when you're reading through options, but you can do whatever you want. All right, let's save that, close it. Query 6. All right, write a SQL statement that shows all of the managers and the city where they are a manager. Okay. Display location, city, first name, last name, position, title, order by location, city. So what do we need here? We need all three tables, it looks like. So this is going to be a slightly more complicated join, but it's still not that bad once you get the hang of it. Create, let's see, query design, close that out, SQL view. All right, select, what do we want to show? Location, city, first name, last name, position, title. Oops. Okay. From, we need all tables. Location, employee, position, where, okay. Let's take care, well, let's do the join. All right, so we have three tables. We need to join location to employee and position to employee. Remember, there's a one-to-many relationship from each side. So 2 joins for 3 total tables means we're going to need 2 of those join criteria statements. Basically, however many tables you have, you need that minus 1 join statements or equals clauses, whatever you want to call it, to connect each of the tables together. So first let's connect employee to location and then employee to position. not that it matters with this type of join in particular. It doesn't really matter what order we do it in. Let's say employee dot location. All right, let's make sure we get it spelled right. Location ID, no spaces. And position ID, no spaces. Okay. Location ID equals location dot ID. Just double checking. Yep, over here it's called ID with a lowercase d. And position's probably the same. Yep, here it's called ID. So this joins employee to location, but we're going to say and employee dot position ID equals position dot ID. So again, it doesn't matter what order we do these in, and actually, truthfully, since location ID and ID are two different field names, I don't have to include this employee.location ID because the field name location ID doesn't exist anywhere else. However, ask yourself this question: do I need location.ID and position.ID, or can I just use the keywords ID? These ones I have to leave here because notice among these three tables, two tables have the same named field. So I do have to specify which field in which table am I referring to when I want to match up these primary key foreign key pairs. Anyway, I wouldn't dock you points if it were up to me if you included table names on every field name that you referenced. Maybe that's just a good habit to get into, but I don't normally do it. Okay, so that handles the join. Next question is, what's our criteria? All managers and the city where they are a manager. Okay, all managers, that's pretty straightforward. So, and position title, like, what do we do again? Star manager. So it gets whether it's a regional manager or just a manager. So to give us an order by, yes, order by location city. Comes at the end, order by location city. Okay, let's run it. There we go. Location city, first name, last name, all types of managers. It all works out. Three tables joined together. Cool. All right, let's save this, close it out. Query 7. All right, write a SQL statement that shows the average salary of the employees in each location. Display location ID, location city, average salary. Not sure why they care about location ID, but we'll give it to them anyway. So this is like the totals query that we did in the last chapter, where we turned on that sum button. There's no button we need to turn on this time. I mean, all the button does is specify what SQL code to write. So we're going to write it from scratch. All right, so let's get our select statement. SQL. All right, so we want location ID, location city, and average salary. So average salary, there is no field called average salary. That's a calculated field, something we have to, something that we have to use a function for. So here's how we do that. We have to always reference actual field names. So we use the field salary that comes here from the employee table. All right, so this is the field. But then much like Excel, we're going to use, I can't remember if it's AVE or AVG. Something tells me it's AVG. Let's try that out. We use a function name, much like we would in Excel, where we pass in the parameter. But instead of passing in, like in Excel, like a bunch of cell references, we pass in the database field name. So average salary, but we also use the keyword as to give it a new name. Average salary as, we'll just call it average salary because that's what they wrote in the, right there, that's what they wrote in the problem. So this says calculate the average of salary and give it the field name average salary. Okay, what tables or table? We know we need the location table, and salary comes from the employee table. Do we need position for anything? Nope. We just want to group this now. So if we're going to use an average or a function, it's implying that we're going to want to group records together to run that function on. In particular, it says in each location. So what we want to do is we want each unique location listed once, and then all values for that location are averaged together in the resulting calculation. So remember what the keyword was in the design view? It was called group by. So here's what we do. Next we need our where clause to join these together. Let's not forget that. Where employee.location ID equals location.id. Now in this case, location ID only appears in the employee table. Notice here in location, there is no location ID, there's just ID. So we can actually kill this employee right there. And there's also only one field name called ID because we're not including the position table. There's only this field right here called ID. So if we do this, it'll still join things just fine, and it's just a slightly bit simpler. Okay, so that joins the fields. That joins the tables. There's no other criteria. We just need to tell it to group it by location in each location. So we're going to use a keyword just like it was in the design view. Group by. Now when we use a group by clause, recall that anything that we're not using a function on when we did this in design view had to have the group by included. For example, here I want to group by location city. But because I have location ID, if I try to run this, it's going to give me an error and say, hey, you're asking for a field in a calculated, or when you're using a function, and then you have this field right here that doesn't either A, have a function wrapped around it, or B, appear in the group by list. We don't know what you want to do with it. It could potentially be a problem. So if I hit run, I get this error. Your query does not include location ID as part of an aggregate function. What you need to memorize or know for this is that whenever you're using group by, or whenever you're using a function, you have to use group by and then include in this list anything up here that doesn't have a function wrapped around it. Now I could do multiple functions. I could say give me average of salary as average salary, give me the min of salary as min salary, as many things as I want, but anything I'm not using that function on has to appear right here. Group by location city, group by location ID. And really the reason why I said I don't know why we need this is because every city has a unique ID, so it's not like this is breaking it down any further. But who knows, maybe your manager wanted this because the report you give him, he needs the ID number for looking something else up in some other system. Who knows why. So even though it may not seem logical, we just say, fine, this is what you want, we can do that. So go ahead and view, and now we have Atlanta, and every employee that worked in Atlanta, their salaries are being averaged together. So each city is listed only once instead of multiple times for each of the employees who work there. Okay, that's how we use group by. Let's save this one. Yep. All right, 8. Write a SQL statement that shows how many employees work in New York City and Denver. So it sounds to me like that's combined. Work in the New York City and Denver locations. Display location city and total employees. Okay, so it looks like we're going to do it's not combined, it's another group by. So, but we want just New York and Denver, and we want total employees next to the name of each city. Not a problem. In fact, see if you can pause this now and do that one on your own. Again, every time you can pause and do it on your own, the more likely you are to truly learn it and remember it for your exams and everything else you're going to need it for. All right. Create query design, close, SQL view, select location city, and what was it? Okay, this brings up a great learning opportunity here. What field is going to give us total employees? What field I can tell you what the function is. There's a count function that we're going to use to count up records. So we want to count up the total number of rows that have New York City or Denver as their locations. But which field do we use? Remember with query 7 back here, we used salary as average of salary for that function. Average was used on the salary field. Now here, I've told you you're going to use count as total employees. The question is, what parameter or what field do I pass in there? Think about it for a second. Let's open up employees. Which one of these should you use? Ultimately, you can use any field that doesn't have blanks in it. If I were to try and count gender, it wouldn't include this one because there's nothing there. Same problem with performance. So what field would be a good one to just automatically use every time you need the count function? Which field is guaranteed to never have a blank in it? That would be whatever field is your primary key. In this case, I'm pretty sure Social Security number is primary key. Yep, primary key is Social Security number. Primary keys can never be blank. So again, it would still work as long as whatever you passed in here didn't have any blanks, but we'll use Social Security number. All right, count that up. Whoops, not where. From location, employee, where. Let's don't ever forget, just get in the habit of doing your join first. Whenever you're at that where clause, get the join out of the way. So in the employee table, it's location ID equals ID from the location table. And we have another criteria. City equals New York, or, and this is a good thing to learn, when I use an or, it's not like it was before in the design view. I can't say Denver like this. It'll give me an error. I have to say, and city equals New York, or city equals Denver. Wait, now I'm second guessing myself. Let's try this out. Nope, yeah. Well, no, that's a different error. Let's come back to this one in a second and test it out both ways. Because we're using a function here, what do we have to use on anything that doesn't have a function wrapped around it? Group by. Oops. Group by here. Location, city. All right, there's nothing else up here in the select statement that doesn't have a function wrapped around it, so that's all I put there. Group by location, city, run, okay. And it says city, enter parameter value. It does that when it's not sure what we mean by city. So let's debug or fix this problem. Do we truly have a field called city? Let's open up location. Nope, it's called location city. And it wasn't, that's why it couldn't find it. That's why it gave us that error. So let's change this to location city. Run it now. And it's giving us everything. All location cities and the same total for all employees. That's because we've got an error right here. Equals New York or Denver. It's not sure what to do with this line, and so it's just taking a guess at what we mean. The reason why it's not sure is because after an or an and statement, we need another one of these. Location city equals Denver. So this is one reason why it might be good to just get in the habit of always putting these operators and an or down the next line, because then it reminds us, oh, I can't just leave it like this, or Denver. I've got to put, like in all of these lines, a field name equals that. All right, group by location city. I must have spelled New York wrong. Let's go back and check. Oops. Okay. And locate. Okay, no, here's the problem. Order of operations matters. In other words, think with your math problems, you have to put parentheses in the right places. In this case, I'm saying where you join this and it equals New York, or ignore all of this, or location city equals Denver and don't join. What I need to do is wrap parentheses around that and this. And in this case, maybe you would want to put it back up here after all so you can see this. So one, it has to be joined no matter what. Therefore I join it and, but then I wrap parentheses around my or. And one of these two things is true. Group by location city. And I'm still, okay, I still got something going wrong. I think I got an idea. Back here, and the reason why something's wrong is I'm only getting Denver, I'm not getting New York. So let's go back to our SQL. So I'm asking for New York or Denver. Can you tell what the problem is? Can you debug it? If you're unsure, go back and let's take a look at what the actual location cities look like. Oops, location. you see the problem now? It's not called New York, it's called New York City. So it's not finding anyone who works at New York, it's only finding people in New York City, so it's not including them. So just come back here, add city, view, there we go. 2 employees in New York, 4 employees in New York City. To double check it, just check here. We've got Denver is 6, New York City is 5. So we should have 2 and 4. Let's check employees. Location, I've got 1, 2, 2 2s, 3 2s, 4 2s. Oh no, I'm looking at the wrong one. It was 5 and 6. That's what I meant. 5 and 6. So I've got 5, 2 5s, 3 5s, 4 5s. And there should only be 2 6s. 1, 2. There we go. Cool. Close this out, close that out. Save query 8. Yep. No, 2 more. Last 2. Okay, write a SQL statement that shows the total salary of the employees for each location. Display location, city, and total. You guys should be able to do this one. The function you're looking for is called sum. So see if you can do this one on your own using the function called sum. Alright, let's do it. Create, query design, oops, close that, SQL view, select, location, city, was that it? Yeah, and total salary for all employees. So we're going to need to use a sum function, salary as total, employee, location. Doesn't matter what order you put things in your from at all. Where location ID from the employee table equals ID from the location table. Let's see here. Group, was there some other criteria? Nope, just for each location. Okay. Group by location, city. And no order by either. Let's order by city, even though it doesn't tell us to. Does order by go here, or does it go before the before group by? Is group by first, or is it last? Let's find out. Let's first make sure this works. Okay, we got the sum for each city. Back to SQL. Let's put order by here, order by location, city. Try and run it. It says nope. Syntax error in query expression. Oh, first of all, I spelled it wrong. That's the problem. There we go. All right. Syntax error in query expression, location, city, group by location, city. So it says we don't understand. Basically what it means is we don't understand this code coming before the group by. Why is it there? In other words, order by goes at the end always. There we go. I think it actually already was sorted by location, city, but whatever. Okay, that's it. Let's save that one. Query 9. Now we're on the last one. Write a SQL statement that shows each of the employees hired between 2 dates. You can choose them or your instructor will during class. All right, not a problem. Employees hired between 2 dates. Create, query design, SQL view, select all from employee, where hire date, and this is just a chance to make sure you can use dates in SQL. Hire date, let's say greater than 1/1/2000. Close that. And hire date less than, I don't know, let's say 1/1/2003. All right, that's it. After 1/1/2000, yep, and before 2003, that's it. All right, you guys, this is SQL. It's not that complicated. I know there's a lot more to it than this. However, this will actually accomplish a whole lot of everything you'll need SQL for. Important to practice this stuff. So, talk to your instructor in class. see if she or he will go over some practices with you in class, and good luck using this in your jobs.